issues of the methodological approach for designing low-energy buildings and their economics is addressed in this lecture. Building envelope design, if we aim to achieve the maximum comfort with the minimum primary energy consumption, requires the integration of the parameters of comfort and energy into each of the critical steps of the design process. Factors such as climate, master plan, building shape, facade design, thermophysical characteristics of materials, and mechanical services must all play a role in decisions. To achieve this result, it is required a high level of integration among the skills called into play in the design process. The design process, nowadays, is generally based on a linear path in 3 steps: architectural design, followed by the design of mechanical systems, of course when the building is equipped with an air conditioning system, and then construction. This approach is incompatible with the design of low-energy, high-comfort buildings. It is necessary to change the design methodology and make use of an integrated design model that includes the introduction of a new professional expertise, the energy expert, which must have a deep knowledge of building physics. The energy expert must be able to interact with the architect and with the mechanical engineer. He must not only be capable of managing simple rules of thumb, but must also be able to use sophisticated simulation tools for evaluating the energy performance of the building, and not only, also thermal comfort, daylighting, natural ventilation, and all the passive means of reducing energy demand. The design process becomes circular, iterative. Ideally, the first design sketch is developed jointly by the architect, the energy expert, and the mechanical engineer. Then, the energy expert makes a closer check of the initial solutions by means of energy, thermal, and visual comfort simulations. If the result is not satisfactory, the initial sketch is modified. If and when the result is satisfactory, then the most appropriate mechanical system is chosen and energy consumption evaluated. Again, if the evaluation shows that energy consumption is too high, either the cooling system is modified or some design choices are revised. The next step is to check the possibility of providing partially or entirely the necessary energy with the renewable sources. Next step is the economic feasibility analysis. If satisfactory, the process stops here and the project is consolidated. Otherwise, the loop starts again until a satisfactory result is achieved. This is the integrated design approach. Most important are the first 2 stages of the design process. The reason is that the most critical decisions about the energy performance of the building are taken in these early phases. The earlier the energy expert is integrated into the design process, the greater the impact on building's performance and the lower its cost. It is not sufficient, however, that the new design process integrates a new expertise, and that from linear it becomes circular. It is also necessary to define a planning strategy, the one characterizing the energy efficient and comfortable building. In the design process, the maximum effort must go into minimizing the amount of energy needed to provide thermal and visual comfort by means of appropriate architectural design. It is the most important stage. Only after this goal is reached, the design team must maximize the energy efficiency of mechanical systems. If the 2 previous jobs are performed well, the amount of primary energy needed is quite small and can be supplied by renewable sources in an economically and financially sustainable way. This is because the higher the energy efficiency, the lower the size and hence the cost of the renewable energy production system. About cost. About cost, there is a common belief according to which low-energy sustainable buildings are necessarily far more expensive than conventional ones. This graph, dealing with a sample of German buildings, shows that it is a wrong belief. Buildings with the same cost show very different energy consumption, and low energy buildings can also be low cost if appropriately designed. In conclusion, integrated design is not only a necessary condition for energy efficient building design, but it is also the main way to control their cost.